Okay, so first one, 53. And that's what I got for 53. So
it is 2 arc cosine of x.
yeah. So for this particular one is y equal to 2x arc cosine of x minus 2 square root 1 minus x squared. The first one is a product rule. So it'll be 2 times arc cosine of x plus 2x times derivative of arc cosine of x, which is negative 1 over root 1 minus x squared. And now I take a derivative of 2, and that's 1/2. 1 minus x squared to negative half times negative 2x. And Maya, that's not good homework. No, I think it's been pretty consistent recently. You gotta be careful. Now is the time for you to never miss homework. Now is the time to be a crunch time. It's fourth quarter. Actually, it's third quarter, but for me, it's like a fourth quarter.
Yeah, I thought it was the fourth quarter of the day. I'm in the fourth ready for sports videos.
Okay, so this one will cancel out to be that way. Also, hey, did you check your answers when you do a homework? Like what we talk about, you know. Yeah, you can.
You can use decimals for these ones.
Yeah, why not? So, for example, I for example, like this is the one of the question I have, which is the f of x, and if I take a derivative, it's gonna be the blue line. And after I take a derivative of that, I compare with the green line, I know it's matching. So I know my answers match correctly. Yes, of course you can. Because you can do f of x and f prime of x and just type in the function that you get for derivative and see what you get from there. Austin, I need to get homework.
Wait, can you go back to your answer?
Do you remember this questions? This is one of the question that you have to do quotient rule. And let's type in the whole thing, and I say, hey, let's check the answers.
Wait, would we be allowed to do this and we'll have a recording?
It was already recorded. And this last 3 of the back.
All right, so
Wait, can you go back to question 3?
sure. Now, a lot of you guys don't know. A lot of you guys don't check your homework answers. Like I say, you're like, you know, that's not how to do it, because if we talk about how Ava practice basketball, you have to do a meaningful practice. That means you have to go observe what kind of things you did bad on, and then how do you fix it. You cannot just do the test, just shoot a ball. Hey, I'll just go out shoot 300 balls. I'm gonna be Michael Jordan someday. If you shoot 300 ball with the wrong way to shoot, you're gonna become nobody. That's probably comes down to the line. If you guys don't make sure that your equation tangent line is the right way, your derivative is the right way, you're always gonna fail the test. I'm just gonna be flat out tell you that. This is another one that I did 63. Somebody asked. You can look at other people did, but I take a derivative of it. I plug in 1/2. I simplify. The simplifying that is actually not hard. I went back down all the way simplified. It's gonna be 4 root 3 over 3. I plug in the equation tangent line. I check at the equation tangent line. How many of you guys check your answers on Desmos? Only 3 students, and that's why. You should see the equation tangent line. Okay, if you don't know how to do it, that's fine. I'll teach you. What was the equation? 2 arc sine of x. 2 arc sine of x. That's the function. What was your equation tangent line? Y minus what? Pi over 3. Y equal to pi over 3 equal to what? 4 root 3 over 3 times x minus what? You see that equation tangent line right here at this point? That's the equation tangent line. Okay, so I answered this question. Do you have to rationalize everything you do? Depend on the question. Is it on free response? No. A multiple choice, all the answers should be rationalized. And for the other one, Laura, this is how you check answer. You type in f of x, right? And you graph f prime of x, and then you graph the derivative you find. And you see they are the same equation. So they are the same equation. See the green line and blue line? They over on top of each other.
Oh, okay.
And that's how you check answer. Most of you guys don't check answer. Only 3 students out of, what, 15 students check answers? It's like me, just go out, throw a basketball up to the hoop, and then hopefully, well, I prayed for them to get in. It's that I have more chance getting in than you have more chance getting right. It's just the way it is. But do homework without checking your answer is meaningless. Like what Nisa did yesterday, I was really proud of him, even though his work is completely wrong. No, I mean like so what happened is Nisa didn't do a homework for like a few times, like 3 or 4 times, and he realized that he started falling behind. And I was looking at his work, it's completely wrong. I said, Nisa, when you have conversation, we talked to him. I said, hey, look, I need you need to find a way to get yourself back on track. And I need you to start doing the work the right way. So yesterday he did do that. He posted his absolutely wrong work online. That's fine, because we get to see like there was a lot of parentheses that's wrong. There's a lot of things. There's a lot of argument issue that's wrong. Same as you guys. It's not different. You're not. He's not less than you, or he's not more than you. You guys are roughly the same. You're making all those mistakes. When I see that you're supposed to do product rule, chain rule, and all that stuff, you guys didn't do it just as much as he didn't do it. But at least he doesn't feel like he didn't feel like embarrassed by posting his wrong work. He's like, I think I did it wrong. I need somebody to help me. That's fine. That's better than you don't do shit at home. Then just say, oh, I did the homework. I don't know if I did it right, but whatever. And if you're gonna half-ass your homework, that's not gonna cut it. Right now it's AP exam time. It's not. You're not gonna half-ass. You're gonna get an A now. I'm not giving you an A. I'm not giving you a B until you learn to work that you're about. You know how to work the right way. The right way is check your answer each time. Dude, I'm checking my answer. I'm going over it. Homework questions. Any other question you want me to go over? I think this one is pretty cool. The one with the you have to do quotient rule. So this is how you check your answers. This is one I did quotient rule. So low D high, high D low over low low. Some people don't see the argument. It's the numerator and denominator are 2 different things. And you have to do low D high, high D low over low low. So if you get to this point, it's good already. You take a derivative. I mean, if you want to simplify, it will look like something like this. But it's not needed because you already take a derivative.
Is this the
This is the final answer is 3x minus arc sine of 3x times 1 square root 1 minus x squared times x squared times square root of 1 minus 9x squared. But it's not needed. If you get to this point, I'm happy with, you know, there's a quotient rule. You know that how to take a derivative of arc sine. And I'm good with that. I'm okay with that. Because well, that's what I did. I checked my answer to see if it's right. And my answer is right. Because Chase last period says, look, Mr. Ye, I checked my answer. They both not come out correctly. I say, well, let me check again. Let me make sure that you did it right. So end up he missed a parenthesis. And then that's why his graph not come out right. But understand the calculator is just as important as understand without it.
Wait, can you not do product rule on this one?
Why? You can. Yeah, you can use product rule. You can move. I saw you did product rule. You moved it to x to the -1, and you take a derivative of x to the -1, x to the -2. I saw that. And then you do a product rule with that one. It's perfectly fine. I just usually prefer if it's a quotient, I do a quotient rule. But that's up to you. That's your own preference. But you can check your answer on Desmos. Again, the problem is checking your answer on Desmos. You can simply take in derivative of that and you can see the answers. I didn't post the answer just because most of you guys can check this. Even at worst, go to ChatGPT. ChatGPT is actually I want to I was watching like a lot of like social medias. They were talking about how to use ChatGPT to study, which is phenomenal. I think little kid in China, they're using DeepSeek to study their math, which is pretty crazy. But you also see the same social media in America. Like you see like those kids are in Ivy League and they study through using ChatGPTs.
So many people do.
Huh?
Somebody, like my brother was saying that he was like, I don't use it to like cheat or anything, but you can use it as like a crutch to like help you like make a study guide and like learn.
Yeah, and also like also a lot of time like they do this. I think in China like learn how to ask questions is very important. So for example, you have a word problem like me and my sister. If 3 years later I'm double her age, and so what is my age now compared to that? So that's the question, and you post on ChatGPT. You can say, well, can you ask me one question at a time that prompt me how to lead to the right answer? That's also another way to do it. So you will say, so, well, who's older? First question, you know, is the brothers older or the sisters older? Second question, what is right now? And then you can ask and you can reply to ChatGPT. Just tell them to ask you questions, one question at a time, and you can make that prompt to ask to build that foundation. A lot of time it's not wrong. So don't like what she said that Ava says is use as a crutch to study, but not use to cheat. I think the problem uses to cheat, you become dumber. But if you use to as a crutch to help you study, you see all those Ivy League students. You see it on like Instagram Reel. They say like this is how I study certain things. I use ChatGPT to help me study to get better, and that's fine. But you gotta use something. You cannot just do the homework without checking your answers. And that's my biggest concern for you guys is like you guys don't check your answers. I check my answers. I want to make sure like I did it right. So okay, so this is another question that he did. And then yeah, did it completely bad, but it's okay because we get to find out where is this misunderstanding is. So like this is the one that is chain rule rather than product rule. I think inverted product rule in this type of situation.
I don't know what it is.
Yeah, no, you have to know what you did. You cannot just say I don't know what
No,
I.
I did product rule first, and then I realized that it was argument.
Yeah, that's argument. So and like I said, Nizar is not the only one that confused. A lot of people are confusing, and that's what I'm saying. I'm proud of Nizar to just post his work out there, like. You know, it's what you guys need to do is start and double check with each other and see like is your work correct or wrong. So what happened is there was an argument of arc cosine of x is within the sine of x. So there's a chain rule. So there's an onion. You're going from outside inside. That's what Abyss says, like onion rule. You take the onion outer layer, you take a derivative of outside, you leave the inside alone, and then you take a derivative of the inside. Now, cosine or cosine is going to cancel out to be x because they're inverse to each other. That's why you get x. So that's why you get a final answer got negative x over root of 1 minus x squared. Yes.
So you don't do like the onion thing?
You did. You did the onion. So the first layer, I'm going to show you a really cool laser here. The first layer is the outer layer. So I'm going to take a derivative to the sine first, and then just do cosine and leave the inside onion there. Now I'm going to take a derivative the inside onion, which is I'm peeling inside the onion. So that's going to be -1 times square root 1 minus x squared. And then cosine arc cosine, that's going to cancel out equal to x. Any other question you want me to go over?
Identity of the inverse of itself is always going to equal x.
What?
So any trig identity, with the argument as inverse is going to be x.
If you not make sure, go to here. Look.
So if it were sine of inverse,
It's not, you're not, it's, you can say it's x, but it's within certain range. Within, like, say, -1 to 1. Because you type in the x right here, so this is the whole thing. Do you see this is owning the between -1 to 1? But yeah, within certain range, yes. This is another question that somebody did. 67. So if you have problem with 67, product rule. Now this time it's product rule. Maya, don't copy down. Do your own work. If you don't do work, that's not how you get. That's not how you pass my class. If you just write down whatever I write down on the board, you're not gonna look at it when you go home. Go back and redo all your work. Yes. It don't need a boundary. It has an initial condition of 1, 2 pi. So I'm plugging 1. The problem is a lot of students confused about what's arc cosine of 0. Arc cosine of 0, even this morning I was kind of like half asleep, but our arc cosine of 0 is actually pi over 2 rather than 0. Because that just means when x value is 0, what is my radian? The only time that x is equal to 0 is located at pi over 2. So that's pi over 2. So 4 times pi over 2 equal to 2 pi minus 4. So that means your slope is 2 pi minus 4 times that. This is the product rule, actually. Yes.
Why can't it be 3 pi?
Because that's an inverse trig, it has a restriction between 0 to pi. And for inverse tan and inverse sine, it's a right 2 quadrant. So it's a negative pi over 2 to pi over 2. So yeah. So that's why it cannot be 3 pi over 2. Good question. So it's not saying 3 pi over 2 is wrong, but just it's wrong in terms of arc cosine.
Oh, yeah. And sine and tangent.
64. I don't have time, but I'll look at this for you. 64. Let me see. Yeah, just plug in. Just take a derivative, plug in square root 2 over 2. That's gonna be pi over 4, by the way. Or actually, sorry, negative is 3 pi over 4. Oh no. Okay, let's just look at 64 really quick. 64 is gonna be 1/2 arc cosine of x, so it's 1/2 times -1 square root 1 minus x squared, and you're gonna plug in negative square root 2 over 2. So this is just simplification. So 1 minus square root 2 over 2 square. I think that's gonna be 1 over 4. Is that right? No, 1/2.
Yeah, one half.
1/2. So 1/2 times 1 minus 1/2. So that's equal to negative 1/2 times 1 over square root 1/2. Two way to do it. I think it's a negative 1/2 times divided by square root 1 over square root 2. So that's equal to negative 1/2 times square root 2 over 1. So that's going to be square root 2 over 2 negative. Is that okay? So y minus 3/8 is equal to negative square root 2 over 2 times x minus 2.
Minus 2.
Wait, x minus 2?
Shouldn't it be plus? It should be plus,
Which one should be plus?
x plus square root.
Oh yeah, that you're right.
Yeah. It's,
Do,
with the x.
yeah.
I thought x plus square root 2 over 2.
Yeah, it has an x.
Oh, okay.
Square root 2 over 2. Yeah. Wait, hold on a second. Yeah, that's right. So ideally, like you should know how to do equation tangent line by now. Hopefully, I we done equation tangent line since like the first chapter.
It's just
It's not going nowhere.
Like,
I do.
like when I got to this part of the homework, okay.
Victoria, have you agreed with the text?
Oh, it says it.
No, we're gonna grade this. Start grading this afternoon.
Oh, like after school?
All right, so questions about this part? All right, so we're gonna talk about new stuff. So imagine that if I take a derivative of I don't know, arc sine of u is equal to u prime over square root 1 minus u squared. Derivative of arc tangent of u is equal to u prime over 1 plus u squared, right? We know this, right? Hopefully you know this by this time. So in that way, we're gonna say, hey, we need to be able to take integrations. Integration of u prime. No, sorry, not u prime. Integration of dx over square root of a squared. Sorry, let me go back to that. Is a squared minus u squared is equal to arc sine of u over a plus c. Now this is a here. Now I have integration of dx over a squared plus u squared. This one's going to be 1 over a arc tangent of u over a plus c. Now this one is extra compared to before. This is 1 over a in the front you had to memorize. Only in the one arc sine doesn't have a 1 over a in the front. So for the next one, it's going to be integration of u square root of u squared minus a squared. This one's going to be 1 over a arc secant of u over a plus c. Now, I will say in terms of priority wise, if you had to memorize two equations, this one is definitely the first one. Or arctan is easiest to remember. It's a squared plus u squared. It's very, very friendly, so no negative signs. The second one is going to be a squared minus u squared. So this is the second start. And this one is almost never happen. So I only give 1 star out of there. It's only happened on homework. You're probably not gonna see it on the test, nor AP exam. So the first two are the one that's like you have to know very, very important. Like you have to know very well. Any question about this part? So this part is something that I would know for the test. Now we're gonna try one. We're gonna say, hey, do you know how to take integration of this? Dx over square root of 4 minus x squared. And this one should be very easy. Everybody in this room should be able to do it. It's pattern recognition. Think about which one this integral is supposed to be. And you can integrate of dx over root 4 minus x squared. Austin's already finished. Mirana's finished as well. Is that right? Amber's finished? No? Am I wrong?
Oh no.
How about the rest of you guys? Laura's finished?
I was waiting on chicken.
The problem is this. The problem people is gonna be like, oh my god, that's so easy. This just means arc sine of x over 2 plus c, and I'm pretty sure I get the right answer. And you're absolutely right. You're absolutely right about this. If you did this, you did fantastic job. However, fantastic job is not good for a lot of questions. So what I would approach this slightly different than you is gonna be a squared is equal to 4, a is equal to 2, u squared is equal to x squared, u must equal to x, du equal to dx. And for me, that's a kind of important to make sure I figure out everything before I actually do it. Yeah. And then that way I can lead to here. I'm still gonna get the same answer. You're gonna be like, yeah, that's a lot of work for nothing. So now I want you to take a derivative of dx over 2 plus 9x squared. In the antiderivative, sorry. I'm hungry. I would say probably nobody will get this one right. Who's confident with the answers?
I'm gonna be confident.
Edison is confident with his answer? Okay, yeah, Edison, go ahead. Edison?
Radical 2 over 2 times
Who's got the same answer as him? All you guys answer are wrong.
And stuff.
Yes? What'd you get? Nope, that's wrong. Yes, Ava?
No, mine's definitely not right. Well,
Try me.
go into it.
No, just say it.
Oh,
Everybody's gonna get it wrong. I predict nobody's gonna get it right, so.
1 over 3x arctan, whatever, if they're explosive?
No.
Wait, can you scroll up? Oh, hey, I think I have one correction.
Can I scroll up? No, I cannot scroll up.
It's a different.
You should have copy done.
Wait, could you do something like the chat too? Okay, A first two. Do you take D? No, D. U equals 3. Yeah, but I'm thinking I can use substitution for the last one. Why wouldn't you put U then?
I would say she's not wrong.
Exactly. Like they underestimate.
Proven wrong, Laura. Proven wrong.
Wait, damn it! Now everybody hurt. And there's just a basket.
No, I don't think that's.
You're confused. I said you were closer. I didn't know what you did. Oh. Wait, no. What if you like swirl? Okay.
All right, so
Wait.
It's gonna be like cosine or something. Is it 1 over 3?
You.
Is it 1 over 3 square root 2 arctan 3x over root 2 plus c?
Bruh. It's different.
okay.
Wait, what is it?
A squared equal to 2, right?
Oh, because you have to do.
A must be root 2, right?
Oh, so I just.
B squared, no, sorry, not B squared, U squared
Their dx different.
equal to 3, equal to 9x squared. U must be 3x. Du equal to 3 dx. See, how people admit like easy steps that get a wrong answer because they admit easy things, but end up to not paying attention to details. Du over 3 equal to dx. So therefore, this is du, right? And this is 1 over third, and this is a squared plus u squared. So there's 1 over third in the front. So now 1 over third times 1 over a. 1 over a is going to be root 2. It's going to be arctan of root of 3x over 2 root 2 plus c. So if you get this, this is the right answer. Good job, Aiden. You can if you want to. It doesn't really matter. Square root 2 over 6. She's in the closer track than you did.
Yesterday I asked you to multiply by 1/3 and you said no.
Yeah, but you didn't have 1 over root 2 over the beginning.
Yeah, I did. I have 1 over square root 2 arctan 3x.
Okay, I'm sorry, I didn't hear it. All right, so does this make sense? So a lot of people tended to don't emphasize the very small, fine things, like small things. If you want to be best at whatever you're doing, always pay attention on those smallest things that you can do, and that's how you become better.
But what was the
Because u equal to 3x, and du has to be 3dx. Because you always have to consider what's u and what's du. A lot of people don't consider u and du, and they don't forget to change your boundary when they do things. So yeah. So including these questions, which kind of format do you think this is? Dx over x square root of 4x squared minus 9? Huh? Arcsecant, okay. But then you have to figure out what u is and a is and du is. A lot of people like don't want to figure out that part. I'm hungry. I am.
Go jump. Sorry, that's 4x.
Yep.
Do like the u squared equals 4x.
Yeah, what is u? Good.
And then
Du is equal to what?
u squared dx.
Good.
But then what happens to the u on the x value? Like, why aren't they the same?
U is equal to what? 2x? What is du? Do you always evaluate dx? Did you do that? So can I rewrite that as du over 2? And this is x over 4x squared minus 9. Now this is going to be du. This part is square root of u squared minus a squared, right? But this is u, right? Because 2x is become u, right? And then that's just going to be the what? Arc secant of 2x over 3 plus c 1 over 3. Because the a squared is equal to 9, a is equal to 3.
Don't you multiply the origin by
Yeah.
What?
don't you multiply the answer by
Because you need a 2x outside. You need less u.
Wait, I'm confused. What is this?
Wait, why is it x? Why did you make it 2x like on the bottom? Like, why is it du over 2x?
Solve for dx.
You plug back in, like your how you. It's like I plug like.
Yeah, so I did it after I did this 2x because I needed this to be u in order to use arcsecant. In this case, it's u now. If it's not, then you had to do something else.
So essentially it's u, even though it's an x. Even though it's an x in the problem, it's essentially your u.
No, it's because this is 2x there. It's not just an x. If it's an x, then it's
Yeah, that's the thing, because like in the formula it's not the x equals right?
no, it's not. It's u equal to 2x. So you had to do du.
X
Yeah, and then you had to evaluate for dx, and you plug in, and that's why the 2 is there coming. But if it's a 3, then you cannot use as u. You had to multiply by other number in order to get that u up here.
Wait,
then what happened to the du over the 2?
I plug in. Look, du over 2 is right here. This is du over 2.
Okay.
And because du over 2 there, that's how they become 2x, and that's how they have integration of du over u square root u squared minus 1 minus a squared. Because you need this u, otherwise if it's not u, then you cannot integrate it.
And just like that's you just like multiplied it in kind of.
No, I just substitute in. I just substitute whatever in terms of u and a and the du. Yes.
For the one that we just did with the 2x, will it always like your
Those are always u and du. I'm just like I'm gonna tell you like I told you that since the first questions, but you guys nobody listen. Except Aiden listened to me.
like will it always
It's yes, you should always pay attention. Even just u equal to x and du equal to dx, you still write it down so that way you don't make mistake. Okay, so how would I do integration of this one? Dx over e to the 2x minus 1. Again, u equal to what?
Oh wait.
Well, u squared is equal to that. Not u.
Yeah, I think it's u is equal to e, and then you put the e next to the bottom. Then it's RT.
How's it work? So
All right. What Austin said is, well, a squared is equal to 1. A must be equal to 1. U squared is equal to e to the 2x, right? U equal to e to the x, because e to the x times e to the x is equal to e to the 2x. So du equal to e to the x dx. Du over e to the x equal to dx. So now I'm going to change the dx first to du. Right? And I'm still do it in terms of x. Now I need to change the bottom part. This is u now, which is a perfect format. Which is the arc secant of u over a 1 over a plus c. So it'll be arc secant of e to the x plus c.
wait, Mr. Why didn't you
Because the format says integration of u times square root u squared minus a squared. But we don't have this u yet. But when we do u equal to e to the x, du equal to ex dx, and if you solve for it, this is e to the x up here. Do you see that from here to here? The e to the x up here there. There's one last question, but I didn't make a video. The last question I'm gonna show you right here really quickly. It's integration of x plus 2 over square root of 4 minus x squared. So I'm gonna make a video. So if in case like this you can split to two different one. This is already in a video. So plus 2 over root of 4 minus x squared. Now in the left case is not arcsine. If you realize this is not arcsine because u equal to 4 minus x squared rather than u equal to x, u squared equal to x squared. Du equal to negative 2x dx. And a du over negative 2x equal to dx. So that's going to be x over u to the 1/2. And this one's going to be times du over negative 2x. This x will end up to be canceling out. So that's going to be negative 1/2 integration of u to the negative 1/2 du. Because I just used the power rule moving up. So if I integrate into this, it's u to the 1/2 times 2 times negative 1/2. So it'll be negative square root of 4 minus x squared. And this one is going to be arcsine because u squared equal to x squared, u equal to x. A squared is equal to 4, a is equal to 2. So it'll be plus 2 arcsine
of x over 2 plus c.
Yeah, I thought until you switched to red, so for him to go back to video.
Oh, look it up after I read. She was pretty good. I think.
No, that. Oh, shoot.
Yeah, sorry.
Why is it negative? Oh,
Because
negative.
yeah.
Yeah, because these we're taking extra time.